Hi everyone, I take this opportunity to welcome you all in my lesson of the day. Today we are going to talk about electronics. So the objective of our lesson will be to define electronics, differentiate between insulators, conductors and semiconductors. Number 3, classify semiconductors. And number 4, explain how intrinsic and extrinsic semiconductors are formed. So, in our introduction, what is electronics? Electronics, it is a branch of science and technology which is concerned with the design of the circuits using transistors, microchips, and with the behavior and movement of electrons in the semiconductors, conductors, and vacuum or gases. So today we shall discuss about electrical materials. Electrical materials are classified into 3 groups, that is insulators, conductors and semiconductors. We shall start looking at one by one. So we start by insulators. These are materials that do not conduct electricity. And the reason why they do not conduct electricity is that their energy gap is so wide. Thus, it is hard for electrons to cross over from this valence band to the conduction band so that to enhance electrical conductivity. It is due to this large energy gap that makes the insulators not to conduct electricity. The next one, we look at the conductors. The conductors, these are materials that enables electricity to pass through them or electrons to flow through them. Their valence band and conduction band overlap, hence enabling them to conduct electricity because electrons are free to move from this valence band to the conduction band because the two bands overlaps, enabling electrons to move from valence band to conduction band, hence enabling them to conduct electricity. Then we look at the semiconductors. These are materials that lie between conductors and insulators. So at times this semiconductor conducts and at times they do not conduct or they behave like an insulator. Their energy gap is moderately wide. So when electrons in the valence band crosses over to the conduction band, then the semiconductor starts to conduct and they behave like a conductor. But when the electrons in this valence band are not able to cross over to the conduction band, then this material or the semiconductors behave like an insulator because the electrons in the valence band cannot cross over to the conduction band. So we shall majorly deal today in semiconductors. We want to majorly dwell on these semiconductors. Their electrical conduction is enhanced in 2 ways. We have 2 ways by which we can make these semiconductors to conduct electricity. One of the ways we can make semiconductors to start conducting is by increasing the temperature. When we increase the temperature of semiconductors, the electrons in the valence band, they gain energy and they jump over to the conduction band, hence enabling the material to conduct Then another way we can make a semiconductor to conduct is by doping. What is doping? This is the addition of an impurity to a pure semiconductor to enhance electrical conductivity. So we are just inducing a substance known as impurity to this pure semiconductor to enable it to conduct electricity. We shall start looking at how the temperature affects the conductivity of semiconductors. It affects the conductivity of pure semiconductors only. Examples of pure semiconductors are silicon and germanium. At zero temperature, the semiconductors are insulators because all their electrons are bound in the valency band, and hence no electrons are in the conduction band for electrical conductivity. But at room temperature, the electrons in the valency band gain energy and jump to the conduction band, and thus the material starts to conduct. Then under doping, we said that it is the addition of an impurity to a pure semiconductor so that to enhance its electrical conductivity. So when we introduce an impurity to a pure semiconductor, we shall come up with the two types of semiconductors. One, it is N-type semiconductor, and two, it is P-type semiconductor. In N-type semiconductor, it is formed by doping a pure semiconductor with a pentavalent atoms like antimony, phosphorus, arsenic, etc. Because the impurity has 5 electrons for bonding, 4 are used to form covalent bond with the 4 electrons of the pure semiconductor, and the remaining 1 electron is used for electrical conductivity. This type of impurity is known as a donor atom or an N-type impurity. Hence, electrons become the majority charge carriers while holes become the minority charge carriers. So, when we have a pure semiconductor and we add a pentavalent atom, then we shall form an N-type semiconductor. As evidence on this diagram, we have an N-type semiconductor or an N-type being formed by doping. This is known as a donor impurity. So a donor impurity, it has an extra electron. So the 4 electrons are used for bonding with the silicon. Then the one which remains, it is used for electrical conductivity. Then we move to P-type semiconductor. It is formed by doping a pure semiconductor with a trivalent atom like boron, gallium, and indium. They have 3 electrons for bonding, while a pure semiconductor has 4 holes for bonding. Hence, the 3 electrons bonds with the 3 holes of the pure semiconductor, and 1 hole is left for electrical conductivity. The holes now become the majority charge carriers, while electrons the minority charge carriers. Trivalent atoms become acceptor atom. The p-type are not positively charged, but they are electrically neutral since the number of protons and neutrons remains equal. So when you take a p-type semiconductor, you add a trivalent atom, you will come up with a p-type semiconductor. As evidence on this diagram, silicon has 4 electrons on the outer energy level for bonding, while boron, it has 3. So the 3 are used for bonding with the 4 of the silicon, and the remaining extra hole is the one which is used for electrical conductivity. So in summary, pure semiconductors, we have pure semiconductors like silicon and germanium. So when we dope this pure semiconductor, we shall come up with extrinsic semiconductors. Under extrinsic semiconductors, they are divided into 2, the N-type semiconductor and the P-type semiconductor. The N-type semiconductor are formed by doping a pure semiconductor by a pentavalent atom, while a P-type semiconductor is formed by adding or doping a pure semiconductor by a trivalent atom. Then these pure semiconductors can also be enhanced to conduct electricity by increasing the temperature. So when the temperature varies from 0 degrees, then that increase, or when we increase the temperature of this pure semiconductor, this material also starts to conduct. Then the material which conducts as a result of increase in temperature, they are known as intrinsic